So in this video, I'm going to show how I was able to image some really distant galaxies using my 10-inch amateur telescope at my observatory by making use of gravitational lensing. And I did it using a very famous galaxy cluster, Abell 2218. And we'll show you kind of the walkthrough of the images and compare to the Hubble images so you can actually see the lensed galaxies in both. Okay, so here's a little picture of the telescope mount that I built for this. I built this back in 2019, a direct drive mount for a 10-inch Schmidt-Cassegrain telescope, a Meade 10-inch f10, so a 2500 millimeter focal length, and it's here in my observatory with a GWO ASI 6200 camera, which has 3.76 micron pixels, bin 2x. So next here, this is the Hubble image of the cluster. And that's a pretty famous image because the gravitational lensing is very obvious. Okay, so the cluster Abell 2218, those are the little kind of yellowish fuzzy spots. Those are a cluster of elliptical and a little cluster of elliptical galaxies that have enough mass that the light from the galaxies behind is being amplified in terms of brighter and magnified and distorted. So these curved arcs you're seeing in here, which are marked with these red marks here, and there's many more of them that I'm showing the marks for, those are distant spiral galaxies or elliptical galaxies that are being magnified just like there's a telescope lens floating out in space. So they're magnified, made brighter, but they're also heavily distorted by the gravity. And that's the way that we can see these super distant galaxies from the Earth, because otherwise there's just no way to see it. And I wanted to know, can I do this with amateur equipment? So as a comparison, here is a picture of it taken with a survey telescope with Pan-STARRS. Okay, and Pan-STARRS is a telescope that's used mostly to detect asteroids. It surveys the whole night sky. There's actually two of them on Hawaii, Pan-STARRS 1 and 2, and they cover the whole sky, and they cover it down to about magnitude 21 or 22 or so. But they don't dwell for a really long period of time, so it's not an exactly great comparison. But you can see here, you don't really see that effect. So we can see, as I'm zooming in here, you don't really see. You see little tiny hints. Okay, so now let's look at my image. So this image is 169 separate images, 1 minute long, all stacked together and composited to reduce the noise. And you can see I got the same field. And then as we zoom in here, let's go ahead and change the image from black and white to white background with black features where it's easier to see the contrast. So you do that and then overlay the Hubble image, and you can see, to kind of go back and forth, you can see those little arcs are actually detectable. So the answer is yes, it is possible, but it takes a long time to get there, and you don't really see much detail, but yes, they're actually there. So those distant galaxies are about 8 billion light years away, and the foreground galaxies, the Abell 2218 cluster galaxies, are about 2 billion light years away. So you can see that you're getting a significant amount of amplification, magnification, and enhanced brightness from the lensing, because otherwise we would never be able to detect them. With amateur equipment, you can detect quasars out at that distance, but quasars are very anomalously bright objects, and it's really, the active galactic nuclei. It's the nucleus of a galaxy that's emitting light towards you that happens to be pointed in our direction, and that can be amplified with gravitational lensing substantially. And that's how we see very distant objects. But these are the first galaxies I've ever imaged at this distance where it's just a normal galaxy.